Welcome, everybody. Good morning and good afternoon for those of you that are in later time zones, like our presenter, Will. Welcome again. This is session 5 of our MTConnect session today. We're going to, just like we've done in the last few sessions, we're going to give it about 5 minutes, let everybody make sure they can get logged in. So we're just going to hang out here for a few seconds. Again, we're using the chat as a function for any questions or anything you guys want answered while during the session. This should be a very interesting session because we're going to go over the history of MTConnect and what functions have been added along the way from 1.0 when it got started to where we are today with 2.6 and maybe a little on what we're looking at 2.7, which is in review right now. So we're going to give it a few more minutes. We'll start up at about 9:05. Just a little comment while we're waiting. So this morning's session is about the history and some of the features that have been added into MTConnect over the years. And then this afternoon, on our last and sixth session, we're going to have Trey McAllister talking about validation and how can you validate that the machines and the adapters and agents you've been given by your vendors are actually putting out proper MTConnect data. Because as we learned yesterday from Neil, during his sessions on querying agents, that if we've got poorly configured adapters, they may not be giving us the proper information coming through to the agent, and then the agents can only produce what it's given. So that was a really interesting sessions on that. One of the things we're going to try to add this afternoon, if you're going to be in our sixth session, at the end of our sixth session, we're going to ask Trey and Neil to join us on the presenter team. And you'll have all 4 of us available to answer questions and, take any feedback as we wrap up session 6. So if you're interested and you're going to be around for session 6, you'll get all 4 of us on the screen later today. So. Trey just sent a comment here. He said he'll also be talking about use cases and real world examples in session 6 as well. So that'll be interesting to a lot of you. Will, while we're waiting for another minute or two, yep. Shannon just posted, says we're currently on version 1.3. What's the upgrade path and procedure to getting current?
Well, a lot of it is working with your OEMs to get them to update some of the adapters and their configuration. Some of the support you can actually do yourself by putting in additional information into the device XML. I think what we can do is go through some of the history today, but the best path is to work with your machine tool vendor who gave you the solution, or whoever your solution provider is for that, for your adapters and agent.
So just to follow up on that, kind of what Neil was talking about yesterday is, in his example, he's now a consumer of MTConnect data with his current job. And so his comment was, I have adapters from all over the place because it's what I'm getting given by my builders. But when it comes to the agent, he's working in the 2.5 agent or the 2.6 agent because he wants all the new features of the agent to publish that data. And we can have him talk a little bit about that maybe later this afternoon again, when we add him back into the roles at the end of 6. But
I can cover some of that while I'm going through the history too.
Okay.
Of how you can add additional information to your device.xml file, such as specifications and so forth. We've added a lot of information in there, and even things like consider the kinematics and other aspects of it that we added actually support the digital twin work that we did, or the visualizations of the model. All of that was added in addition to what the vendor had already provided. So it's all part of the standard. You can add that in additionally, and it can give you a lot of extra capability. But from a data perspective, you're still going to be limited from data out of the machine by what the machine can produce. So if you want more data, you really need to go and find out how to source that from either the existing adapters you have, additional adapters, or your OEM.
Yeah. I thought that was interesting yesterday, Neil, talking about adding an MQTT function in there to allow additional data coming from a machine, taking what you can get out of the adapter directly off the control, but then having the ability to adding sensors or other input from the operator coming through MTConnect that can be added to that machine as a way to extend what the limit is to what's being there. So, all right, we're 9:06, sure. So I'm going to turn it over to Will, and we'll see you guys a little later.
Hi, everybody. Yes, welcome back. For this presentation, it's kind of a marathon. I have somewhere on the order of 100 slides. I'm going to start out with the history of MTConnect, going all the way back to around 2008, when we first started this thing. Well, actually, we showed it at IMTS. That was version 0.1. Version 0.1, or 0.9, was very minimal. It had just a few components, a few data items, and was enough to be able to show that we can get data from the machines. We had 25 people hooked up. It was quite the process trying to get everybody compliant with even that minimum version of MTConnect. It was, a year of training and adapter development and working closely with a lot of the vendors out there. Of course, now we've been going on for 17 years. Up to version 2.6, 2.7 is now in a 90-day review for the people who participated in the development of it. And we've come a huge way. What I'm going to do is go through some of the additions. I'm going to try to do this quickly, sort of pile through in about an hour or so. One thing, you can actually get all of the version history of MTConnect by going to the model portal. And basically, you can see all the versions. You can see all the changes that occurred for a particular version. So we'll list out, what was deprecated, what was introduced in that version. For any item in the standard, such as this is the characteristics, you can find out when it was introduced and when it was deprecated. So if it was deprecated, it will say when it was deprecated. The same thing for any property or relationship. They all have they're all tagged with when they were introduced and deprecated. So you can see when certain capabilities were added. So if you're going to talk to somebody about, so what we were just talking about adding a certain capability to the standard, you know exactly which version of the standard you need to target for that. So let's start with version 1.1. This one came out, I think, in around 2009 or so. And the big thing that we changed in 1.1 was we went from alarms, which were just events, to conditions. And what we were noticing when we did this is that just saying that alarm is active or inactive wasn't really working as an event. Because for one type of event, let's take a system event, you could have multiple different alarms going off at the same time for different native codes, basically like a PLC condition that was in like a warning or a fault. You could have multiple different PLC alarms going off at the same time, and they would clear in random order, which basically meant that there was no way for us to indicate that alarm A, alarm B were currently active when you did a current. So when I did a current, I wanted to be able to show these alarms are active and these are not. So what we ended up doing is putting this idea of a condition. It was a new category of data items. So we had 3 data item category. We had 2 right before that. We only had event and sample. As I think Neil described yesterday, events are either states or messages, and samples are analog or continuous variables like positions and temperature, etc. So we needed a third category, and we added the condition. Now, a lot of times you see alarms and they'll say like a severity from 1 to 1,000 or whatever. We decided to go with a simple 3-state. Normal being everything's okay, warning being we're trending towards something bad happening, and fault being something bad has happened, the machine can no longer function, or this component can no longer function and needs manual intervention to repair it. So we had a simple 3-level. There is a severity code you can add as well, and so forth. We also added the path to support multitasking machines. The big change to 1.2 was we added assets. So before we only had probe, sample, and current. And if you were in yesterday's session, again, Neil demoed that. Assets were the capability of having a key value store. So we could have, you could say, these are a whole bunch of things that are used in the manufacturing process. Now we have a lot of different types of assets. We have files, processes, raw materials, cutting tools, of course, pallets, fixtures. So we have a lot of different asset types now in MTConnect. So they weren't something that were basically like data continually changing. They were just a model of something that you were using. Like, here's how my cutting tool is put together. Here are all the measurements of that cutting tool as reported by the presetter. So that was 1.2. In 1.3, we added a lot of capabilities to report on what the state of the machine is. So we added this thing called functional mode, which would allow you to say whether it was operating or in maintenance or whatever, and programming modes. We also added things like different types of feed rate overrides. So before, feed rate had an override subtype. We made that a thing and then said how you could override it. And we expanded things like controller modes and added filtering to samples. This was so that we could have filter out data by change, how rapidly it changes, or the delta, or by time, so how many times a second you'd want to see it. So functional mode, yeah, we added production, setup, teardown, maintenance, process development, and these allowed us to better state if the machine is capable of doing that, what state the machine is in, because it's very hard to tell whether the machine was either maintenance or just somebody jogging around the axis. So if often what this was produced by was actually a secondary adapter that was added to the machine, or some additional UI that was added to the machine, so that the operator could give this feedback back, and it allowed for us to better understand the utilization of the machine. And then also program edit mode. So this is basically when the machine was in program edit, whether program was being modified, and we also added later ways of being able to track whether it was the foreground program or another program. So this was this is to get a better idea when you're doing the data analysis and availability analysis, what was going on with that machine. If somebody's modifying the program, you may want to know that, because if things change after that modification, then you have a better root cause analysis. So this was a very important one too. And this is like from a controller mode. This is, whether you're in automatic mode or manual, these are all manual modes: rapid, home, your multipliers, and tape and memory and MDI we have manual data input mode as well. So it can either be tape, memory, or manual data input. And then we added edit. So edit mode. Again, these are all manual. Again, the same thing. These are automatic as tape and memory, manual data input, and then edit mode. And this, again, when the program edit mode was active, we could tell what program we were editing, and that would then allow us to, again, note exactly what was being modified and when. And these overrides, like a path read rate override, again, allowed us to break out whether we were modifying the path read rate for the main, or whether it was also or a rapid, so subtype rapid or subtype actual. So rapid would tell us that it was a rapid read rate override. And again, we added extra controller modes for edit and a couple of extra execution states for feed hold, program stop, optional stop, and program completed. This is actually going through history, so these are the additions to execution states right here. And we have all of this defined within the standard. So if you actually look in the model, you can see all these definitions for like controller modes and execution states. And we have all these normative definitions that you can add to it. You can review. And filtering. So actually, this has changed now, the way we do the filtering, but basically you can filter by a absolute value, like whether the number changed by like 0.01, or you could say that it changed by a percentage or whatever. So we can do many different types of filtering, and we can also do it by time. So you can say that if something changes within a second, then report it, or else not. We created another thing in 1.2 as well, which was asset archetypes. So if you think about a cutting tool, there's a physical cutting tool which you measure and you put on the machine. There's then the general kind of cutting tool, like I don't know, a 1-inch end mill. That 1-inch end mill with a certain number of, let's say, inserts and such, that's a certain type. Every cutting tool of that type is going to share the same solid model. It's going to say the same normative measurements. In other words, it's going to be, a 1-inch diameter and so forth. So basically, we have a set of common attributes for every tool of that type. So we created this thing called an archetype. Archetypes are basically templates that allow us to understand, like for a process, this process is executed in this way, usually, or these are the ways that it can be executed. When you actually go and execute this process, you create the actual process, not the process archetype. And that actual process that you're creating is the real one that tracks every single step along the way in the real machines that it went to, not just the ones that you think it's going to go to or the set of machines that it may go to, but the actual ones that it went to. So we had this concept of an archetype, which we introduced at this point as well. Oh, sorry, that was 1.3. 1.4, sorry, I'm going to go fast. We added additional line labels and line numbers. Before we just had the line of the program, but some programs had labels and they wanted to understand at what label, because you can loop and you can go back to a certain line label, but know what line label we're currently executing. So we added that. We allowed timers and counters to be reset. More types of components. We created something called auxiliaries, which were things that you could add to the machine. Let's say your waste disposal system went out. We don't need to shut down the entire machine. Maybe we could still run. So auxiliaries are things that, like even environmental sensors and things along that line, that would tell us about things that were sort of connected to the machine, but maybe not key to the function. In other words, if they faulted, the machine may still be okay. Depends. And then we added a lot more systems like enclosure, which represents the surrounding parts. You can have doors and other things like that. Protective, like if you have a light screen or whatever. Process power, feeder systems, dielectric. We did some work for EDMs and so forth. And then added a bunch of timers because people wanted to know like how long loading took, working, operating, so forth. These were timers that we were exposing from the machine itself. So For line numbers, basically, we could report out the relative line number versus a label. It's like, we're at N100. Line number 0 means we're actually at 100. But then we could also say like we're at line 200 and and line number 1. So offsets. These are offsets. Line numbers are offsets from line numbers. That's an optional thing. You can specify that in the data item type and subtype. So filters. So there's this minimum delta concept that I was talking about. So minimum delta is the minimum change that the data item has undergone. So we could filter out like, don't report anything in a temperature that changes less than 0.1 degrees, let's say, or even 1 degree. Let's say you only care about like a 1 degree Celsius change. We don't, if it's less than that, if it's like reporting out to the 100th, we really don't care. So that allows us to do filtering. And then period delta says, I only really care for this data item report out, let's say, every 100 milliseconds. I don't care if it changes every, let's say, every millisecond. So what we allow is for you to say that you want only changes if they occur in, let's say, 1.1 seconds or 100 millisecond intervals. We don't care if it's like, 10 or whatever. You can actually combine these two together. You can say that you only want to see things that change every 100 milliseconds, 0.1 seconds, and that change by, let's say, a value of 0.1. So let's say your positions are reporting too fast. You can stem that flow if you don't want to get all that additional data, because sometimes your application can't handle it, and for you it's noise. So we can do filtering right at the agent level. The agent supports this. We also allow timers and things to be reset, and even counters to be reset. I'll go through that a little bit later. Basically, we added this idea that we have a reset trigger, and the reset trigger can be on the day, life, maintenance. These are all the different types of reset trigger enumerations. So in the data item, you'll see something that says reset triggered, and I'll show you an example of that when we get to part counts. So I can say every day I want to reset my part count. So at the beginning of the day, the part count will report 0, and the reset triggered will be day. So then you know from your application that this data item, the part count, is now 0, and the reason was it's a daily reset. So we can report that directly out from the agent. The nice thing about that is that it stops the application having to guess, why did I suddenly go back? Why did I go from part 1021 to 0? Was it the machine was reset? What was the reason? So this allows us to report out that reason. So here's an example with like total. This is accumulated time, total cutting time, and we are resetting based on the life. So that is a tool-related trigger. In 1.4, we have all these auxiliaries: lowest weight disposal, bar feeder, environmental, and sensor. These were things that were added again, that were additions to the machine. That's actually a big release as well. We added compositions. I think Neil went through this yesterday, so you were in yesterday. You may have noticed a little bit of this. Basically, we were trying to make it easy to be able to add additional components, but sort of leaf level components. And actually, you can add these as leaf components now too. The big difference was that compositions cannot have subcomponents. So there's nothing underneath motor at this point. Basically, you have a linear x-axis. It has motor, amplifier, power supply. As compositions, the data items can reference say that this temperature is about this motor, this temperature is about this amplifier, and this temperature is about this power supply. And I can have 3 different temperatures, and they can all then be properly classified without having to create a bunch of subcomponents. It's really a modeling decision now, but this was added especially for use with things like conditions. So I wanted to have like a fault on my motor in the linear x-axis. How can I easily state that? Well, I create a motor composition. I create a, let's say, a system fault, and then I attach it to my motor composition. And here's an example. So I have compositions of ball screw and motor, and the composition ID, as you can see here, this servo, this temperature, as I just described, is associated with this motor, and this temperature is with the ball screw. So we have a temperature sensor on our ball screw, and then we can track those within this guy here. And in 1.5, sorry if I'm barreling through too fast, but this is, we had a lot of history. 1.5 was a big one. So also we added this concept of data sets, and Neil demoed that yesterday. Data sets were a way for us, originally the way we got to data sets was we needed a way to be able to represent things like user variables and PLC registers. And it wasn't an easy way of doing that. Basically, we created a data item for every single one of those, and sometimes they didn't have really a nice back vocabulary, a type, subtype associated with them. So what you'd end up doing is having this like huge extended vocabulary. You'd have like, 100 data items, and it was getting just ridiculous. So we were like, okay, how can we make that easier? And also, how can we make this work with the current system that we had? Let me just jump ahead a little bit. And the idea was that, again, so here's like a bunch of registers. These are keys, variable data set. These are variables in the machine tool. So the idea was we can represent all of these guys as sort of a key value pair set. And then the idea was, okay, how can we also make this so that every single time one of these variables changes, we don't need to report out the entire set. So as we do with everything else, everything is report by exception. So when you do a current, you can get every single variable in that data set. As you do samples and as you get changes, what you'll notice is you're only going to get that one entry that either got changed or deleted. There's a removed attribute here for every single one of these. That way, it reduces the load. Like, let's say you have 1,000 of these things, like here we have 100 to 966. We don't want to get 1,000 pieces of data every single time we get a change. So that's one of the ways that we have efficiency within MTConnect. We can just tell you which particular entries have changed with these guys. Another thing we did within this release is we did additive. So with our additive working group that was led by actually Stratasys, we started to create a bunch of new data items that allowed us to report out what's going on with additive machines, like deposition volumes, rates, acceleration. So this is all respective to the amount of material that's flowing through the machine and deposition density. So all this deposition related stuff we added to the standard. So actually MTConnect now supports many different pieces of information, components related to additive manufacturing. And we added additional types for programs. So one of the issues we had before as well is we had this idea that we had a main program and subprograms. So we wanted to be able to say, okay, we have the main program, we have scheduled programs that are going to be executed. And then we also have the active program, the one that is being executed at this moment. And you can report out all those different things. So you can say, okay, this is the subprogram that's executing off of this main program. So all of this is down there as well. So again, I mean, somebody was asking about like if somebody only supports 1.3, how do you get this? This information needs to be reported out of the controller. So if you can talk, a lot of this is available in a lot of the APIs. So if you talk to the vendor, you can probably get this information out from the NC. This is NC related data. Program comments, we were able to now get the header or comment that was coming out of the program. So comments are sort of a hit and miss thing though, just warning. When you get comments out of a controller, often what you're doing is you're sampling the NC and saying, okay, what line, what block are you currently running? What is comment? Sometimes they consider report them out. Sometimes if you jump over that comment because you just miss it when you're sampling, you won't get it. So don't rely necessarily on the comments always being there. It depends on the controller and whether it reports it out specifically and whether you can grab it through grabbing the blocks as they fly by fast enough. So that's all really dependent on the controller and how it reports that information. Program headers are usually a little bit easier. Sometimes it actually requires you to DNC or download the program and then take like the first set of lines up until you get to the end of that program header. But now we have a way of reporting that out for, again, the schedule, main, and active programs. So you can tell, and that's actually sometimes very important because sometimes a program header also contains things like your part ID, some process information that's associated with that program, a whole bunch of other stuff. So yeah, that was a very important thing to mine when we were trying to do like process analytics and understand what's running on that machine, even part type or so. Wait states were important for actually additive and other things. And this became very important also for some of the stuff that we were doing in robotics. So we were able to allow for the machine to say, it's waiting to power up, powering down. We were also pausing or waiting for things like, when you're waiting for the extruder to heat up, we could say that we were in a wait state now. And, or, part unloading and loading, tool loading and unloading, materials and so forth. So we could state any of this. Secondary process was just any, it was a nice catch-all, as was, pausing, and then we're in a resuming wait state. We're just starting up again, and we're not doing anything. So this was very important. If you're doing things like time classification or interval classification for things like, let's say, OEE analysis, you want to know when your machine isn't making chips. That's a very handy data item to have. Again, these are things that you could ask for. It was all 1.5. 1.6, we created revolutions per second and accelerations on those, so revolutions per second squared. And we reworked some of the execution states, new compositions. We added a table type, and again, that extended our data sets. And that was added mainly for work offset, so I could have an XYZ. We had new schedule types of the program header data item, and the compositions also had a table type. So you can report data items in a table for your compositions. That was a new thing that we added. So the ability to create sort of a simplified way of reporting out a set of data for all the different composition types that you had. And we also added coordinate systems. So before we just had sort of a way to say, this was either the work or machine coordinate system as an enumeration, but then you had a coordinate system ID. You could actually have all of the offsets. This is as we started getting into, mapping out processes for digital twins and such. Like now you could tell how the machine was moving relative to some coordinate system, to the machine coordinate system or a work coordinate system, and what those offsets were as well. So we had a whole bunch of new ways of being able to talk about that. Yeah. So an interesting thing about tables, I thought we had an example, but an interesting thing about tables is that we actually had, so when they report out, the changes are going to report for an entire row. So like with a data set, for each of those items that changes, again, we're only reporting deltas. When you report a delta for a table, you're going to report out the entire row of that data. So every piece of data that's changed for that. And what that allows you to do is they have, let's say, a work set offset table. So I have like my my G55s or whatever, so your different type offset sets, and those can be for your X, Y, Z, A, B, C. So you can have a table with those column headers, and then for each of the different offset groups, you can say what those sets of offsets. This has actually become very handy for all sorts of things, and we're even now doing it in the latest version as an option for reporting out things like coordinate system transformations. So now you can, instead of having to say, X space Y space Z, you can say X, Y, if those are the only two transformations you want to have. So some new fun stuff, but tables gave us a lot of flexibility with, within data items. In 1.7, we added something called the agent device. So as we're moving forward, we were able to update the agent dynamically and say things like, I've added a new device or removed a device and so forth. That's in the later versions. But we also want to be able to talk about the connection status of various different adapters, whether they were connected or not. There was no easy way to do that. You just get unavailables for everything. Or, you had, let's say, 3 adapters that are feeding data to one device. We can only say that, these data items are unavailable. Why? Was it the adapter that was on, the adapter itself that was disconnected from the machine or died? Or was it that the adapter is no longer reporting, is saying the machine is no longer reporting data? The machine may be off. So we want to be able to say what the connection status of that machine was. We wanted to say what the URIs of the data of the machine were. And we wanted to be able to say things like, software versions, and all this other stuff, all these things that were associated with that particular adapter that was being reported to MTConnect. We also had the observation rate. So you could tell how fast observations were being updated, how fast assets were being updated, and all that kind of stuff. So now you can actually get statistics out of the agent directly by looking at the agent devices. Special device, you can actually turn it off if you don't want it, but every agent past 1.7 has this new device type, special device type called the agent. We also added a bunch of things around the parts. So part IDs, part kind IDs, part group IDs. So you can start talking about parts, your statuses, unique IDs, things along that line. So this was we added these things called part occurrence and process occurrence as process. And these allow us to talk about all the information about the processes that you're running, the parts that are currently going through, which parts are being made. You can have multiple different parts of the machine at the same time, their serialized IDs, and all that kind of stuff. So we now have a component that can represent all of that information. So this was a big addition. We were working on parts and processes at the time, and if you, all the way now in 2.7, we have part and process assets. Those work in tandem with these components and the various different data items that talk about what's happening in real time on the machine with respect to those parts and processes. We added this new thing for kinematics as well, for structure, and we added motion. So we could start talking about how the machine was put together, the links, how it was connected together. This was for things like robotics. So how do parent-child relationships? So attachments, how is this part attached to this other part of the machine? And then things like the X and Y axis or the rotary axes can then be attached to these links, which are solid pieces of the machine, and describe how they were rotating relative to each other. So this is a lot of stuff that happened in 1.7, as well as we started getting into like tooling delivery, tool changing, turrets, and all those kind of things. So a lot of new components were put into 1.7. The fun stuff is solid model. I could talk about the reference to it. So if you've seen the demo that I did with respect to in the first session where I showed you those visualizations of the machines moving, that's actually done using the solid model portion of the model. So I create this set of solid models in the configuration, and I say that the href points to, let's say, an OBJ file or an STL file or a step file. And then I can say that I have a reference within that. I get the media type. It could be like, let's say, step or STL or OBJ or whatever. And then what coordinate system it's using, the native units and the units. So I can scale that to the appropriate size to display it. And then I can also translate it and rotate it. So I can move it into place. Let's say you have a bunch of STLs and they're all just kind of stuck in the middle. I can move them all to where they need to be relative to the 0 point of that machine. Then I have the ability, through the linking of these various different structural elements of the machine, to then describe how the motion works. So I can say, this piece is connected to this part, this component is connected to another component, and the motion of that is relative to this parent. It's using this coordinate system. How my actuation occurs for this motion. So if you think about in robotics, you can have motors that are moving things, but sometimes you'll have joints in a robot that are actually passive. They are dependent on the parent or another motor to make them move. In some of the some robot types, you have that type of actuation. So we can describe this is basically so you can build digital twins of your machine. That was the objective here. And then we have translations and rotations. And now we can do those, as I said, with data sets. So I can have axes data sets and origin data sets and all that kind of fun stuff. So this capability now allows us to be very specific. People have asked us to put things like matrices in there versus the Euler type notation. If you want that, that's something that we could discuss within the working groups. That was a big change. Now we're able to basically represent a model and do sort of a digital twin of that. That's actually post 1.7. And we created, well, we changed models to, work offsets to tabular form. That was in 2.2, so we changed some of the structure. That thing. In 1.8, we also added a whole bunch of things to represent load counts, uncounts, transfers. These were, again, this was starting to get into robotics and automation. We were working on the metrics for how many times something had been loaded, unloaded. A lot of this was around automatic loaders and unloaders and transfers and things. We could also represent now things like conveyors and a bunch of other types of devices. We then went into things like added a bunch of additional subtypes. We had all that good when we originally started out, but then we added like, target remaining complete, failed, aborted, all these different cycle types, subtypes were added to the standard. Again, we had another working group that was very active at the time, thermal working group. We were focusing at the time on autoclaves. So we wanted to be able to represent things like valves, whether valves are open or not, vacuum, pressurization, airflows, all that kind of stuff. So we added a bunch of new components and data items to support thermal processes. This includes things like heat treat and autoclave, anything, uh, you know, putting any process that basically allows for some thermal variant or pressure variant to occur as part of the information you want to collect. We also added a new type for this is actually for the additive group. But it was very relevant to everybody. Basically, we could now describe the material that was being used as an asset. So raw materials, volumes, and lots and so forth. So we could have a general type of raw material that was manufactured and then the lots of that material. And so this is a brand new asset type that was created. And again, because of volumes, if you have like a container of powder or something, this would allow you to describe that. We have things like container type, the type of process it's going to be used for, serial numbers, and all that kind of stuff. So we were able to represent the material flows through the process. And let's see, we added units we added these release dates and install dates as part of the hardware specifications for the control. So you could now say when certain type, actually this is a configuration too. We were able to say when software was, or when your control was installed, or when it was up, when the hardware was released, and all of these types of things. There's types and subtypes for the machine, so you could tell when something was maintained or upgraded or whatever. So we were able to better report some of the information around the machine's software. Another thing we added was QIF. So if people are familiar with Quality Information Framework, it's a metrology standard, probably the one that's the most used right now by most of the CMM vendors. And it's already a complete standard. So I mean, if you look it up, we can give links afterwards. Basically, it's produced by an organization called DMSC, Dimensional Metrology Standards Consortium, another standards development organization. And what we did is we allowed MTConnect as an asset to transport or deliver the quality information framework documents. And there's a bunch of them. There's plans, results, statistics, rules, etc. Any of those types of documents, basically we wrap it up here. We say, okay, this is the document type, and there's an enumeration. And then we have this block, which is basically just whatever the QIF document is, can get wrapped up in there and sent along. So this gives us a nice way to be able to you can do this for other standards as well. Any standard that has some form, we can basically just report as a MTConnect asset. And this allowed us to get data off of CMMs using MTConnect. So you can report on the the CMM states, as well as then once it produces the document, usually just stores it on like a file in the file system. Now MTConnect can announce through asset added or updated that asset is now available for you. The components, we officially added parts and process components. Were put in 1.7, so we had the process occurrence ID and so forth. And these allowed us to observe a whole bunch of things like part ID, unique ID groups, and so forth. So that was all part of this as well. So in 2.0, we made a major change. So up until 1.8, sorry, that was we were doing the model was released, and the normative document for the model was a PDF. So up until 2.0, we were saying that the PDF is our normative document. The XML schema was derivative. Everything was derivative of this 1.8 set of PDFs. So if you look, that's what defined the standard. In 2.0, the reason we went to 2.0 is because we switched to making the model the normative of the standard. Basically, it was SysML, and a SysML normative document means that basically all of the definitions that we do, everything that we create in the standard is defined by the model. The standard, when you see the PDFs that we generate, the schema that we generate, anything we generate from the model is not the authoritative source of truth of the standard. Authoritative source of truth, if you ever want to know exactly what is the authoritative source of truth, what is the definition of any of these things, you go to the model, and the model definitions are what make the standard the standard. So this also means that when you get feedback, it's relative to the model. So when we talk about, changes to, let's say, configuration or a definition, we talk about it with respect to the model, not like a line on the PDF, but within, the configuration block, the has-solved model property needs to be defined slightly differently or something like that. So that was a huge change. And while we were doing that, we also added some additional types, like acceleration. We added maintenance tables, so we could, again, here's an example of a maintenance list table. So you have, different maintenance categories like A1, A0, and then you can have different types like last service check, the name, target, value. So basically we can have these as defined. And what we do sometimes with these guys in the model, if you look at like a table, you'll see that there are a set of enumerations for the keys. So the keys should have a certain set of specified keys that define what they mean. It's like target has a certain definition. We define all that. For things like measurement, like we have a feature measurement now, each of those are defined specifically. We added a new asset type as well called files. So this allowed us to now represent things like a file that was the production programs that I'm transferring to my machine. So I could say, my machine, we didn't want to store the entire file directly in MTConnect. So we wanted to say, okay, this is the location where you get it from, either like an HTTP or a file, whatever. And this is the creation time. We can also have a secure hash and everything else associated with it, and states. So basically, we created this whole new file asset type. And as I mentioned before, we have these new workset offset tables, which allow you, again, like these are my G54s, and my G54s, I can then say, what my offsets are. So we introduced the work offset table type into the standard. We used to have work offsets, which used to be in tabular form, and then, work offset versus a work offset table. So there's two different pieces to it. There's work offset and work offset table. Work offset is the current offset that is active, and then work offsets table is the table now in 2.2. So that gets a bit confusing. Sorry. We need more time to go over that, probably in a different session. But this was the way you represented it pre 2.2. And then we added this new data item at the device level called asset data counts. So an asset data count set tells you how many of each type of asset you have. Like I have 301 cutting tools and I have 170 files currently in my asset buffer. And that tells you exactly what you can query for. So you can actually query the asset buffer by type as well. So I can say, give me all the cutting tools. I can, give me 300 of them if I want 300 and so forth. So that was 2.0. So 2.0 actually added a lot, and we went again, all publishing and everything changed. 2.1 added batteries. So we were talking about power sources. When a machine's power went out, we were operating off battery. We would then be able to talk about the battery capacity. This is also for batteries that do backups on things like axes and so forth. If you have a battery in there that's rechargeable, or or some part of the machine requires a battery, we could represent it there, charge, discharge. We added displacements for linear and angular displacements, and a leak detect. That's actually for vacuum systems. That was also added as part of some of the thermal process work that we were doing. In 2.2, we added sensors, so sensor states, the work offsets that were mentioned before. So you changed, again, from this work offset table. The work offset now is only after 2.2 for saying currently G54 is being used, or G54.1P1. So we say what work offset is currently active. That was confusion between work offset and work offset table. It was difficult to document. So we end up creating this new thing called work offsets that disambiguated the fact that I was talking about. And work offsets can only be represented as a table, must be a table. And that just makes life a little bit clearer. We added measurements, feature measurements, and characteristics. And that actually was in alignment with QIF. QIF has a concept of features for things like, let's say a hole or a slot or whatever. And then you have characteristics like diameter, distance between planes, flatness, etc., surface finish, so forth. So basically you have a whole bunch of characteristics and then you have a whole bunch of measurements. And we use the vocabulary coming out of QIF to represent, if we can do, and this is something that's like, something would be great for machine tool builders to put in there, is what feature and characteristic or what feature am I currently working on? Am I drilling a hole? Which hole is it? What's the UID of that hole? And that's very important for traceability. So that's one thing. And also in the, sorry, I'm trying to hurry up here. In the configuration, we added this idea of parameter configurations. So parameter configurations allow you to specify the state of various different variables for, let's say, a PLC. This was important when we were talking about things that weren't necessarily CNCs. So when you had something, let's say, like an autoclave that had a PLC with a bunch of different registers, and you wanted to say what that configuration, what the set of static configuration of that PLC was, things like ramp rates or variables to your thermocouple, what your TID parameters were, if you know what that is, basically how the temperature approaches a certain variable or a certain value, and how you configure it to approach that and slow down if you have, as it's starting to get to that temperature. So you get the exact temperature and maintain that exact temperature. So things along that line, configurations for flow rates and all that kind of stuff. We wanted to be able to represent those in the description of the machine. The other thing that we added, because part of the problem we had is that people were saying, well, when I start up the device, or I had to start up my agent, I don't know if the device file has changed. And if it's changed, I want to then, re-import it. So I do a probe. I want to know, okay, has anything changed since the last time I did a probe? Nothing's changed, no reason. I'll just go ahead and do my currents and samples. If something has changed, I want to reprocess all that data. So for devices, we added this idea of hashes. So everything, the whole device basically gives you a number, or sorry, it's not a number, but it's a base64 encoded secure hash. If that means anything to you. Basically, it's a number that if anything changes anywhere within the, it's a very long number, anywhere within the entire device model, this will change. So if an ID changes, if a type or subtype changes, if anything associated with it changes, but I mean, not if you like edit your device file and add an extra bunch of white space, we don't care about that. This just looks at the content. Anything changes in the content, we change this value of the hash here. And that makes it very convenient. This also was something for cutting tools and other asset types, files, etc. So people were saying, well, when I restart, let's say the agent restarts and grabs all the cutting tools again from the machine. So let's say you have 300 cutting tools in the machine, and I load those all into my asset buffer, and I want to say, okay, what cutting tools have changed since the agent restarted? So the instance number in the agent changes, and then we start looking at all our cutting tools. Again, from an application standpoint, I can quickly run down all of those cutting tools and say, well, if this value here, this hash hasn't changed, then I know it's identical to the last value it reported out. If it has changed, then that number will change. And that allows us, again, to very quickly identify changes anywhere within the entire model, because cutting tools can get pretty large. If they have like a whole bunch of different cutting items, and each of those cutting items reports out its measurements, then you can have, pretty large asset documents. So this was a new thing that was requested by our community, and it's now part of the standard as well. Again, implementations of the agent, the reference agent uses this style of hash. It comes out to be a very, very big number. And there is almost no chance that any change would not be recognized in a change to that value. One in hundreds of billion chances. So that was a big thing. We also added this idea of an asset as an image file. This allows us to communicate things like pictures of parts and other things. There's an href, media type, and name. It's a very simple type. And that was, again, for things like if you're doing a digital twin, you want to have a picture of the part that's being made, or you want to have pictures of anything. Not so much in the solid model that we had before, which were like the machine to kinematics, but this is more just additional images or pictures of the machine for display, let's say, on your application. Now we're getting close to our current version. We added in 2.3 locations. So this was the beginning. There's more locations to come, but basically we want to be able to say like where a machine is located, the address, geospatial coordinates, and all those kind of things. So we added this idea of a location. Location can also be part of something like a part or whatever. You can attach those configurations to assets now as well. So anything you see, actually, new thing, anything that you can see as configuration for a particular component can also be used in assets now. So that's probably almost enough for a course on its own, but basically there's a lot of additional information that you can include basically for free. Again, because we're using a model, we have a lot of reusable components that you can attach to any asset that you want, like a process. You can put specifications on that process. You can put process specifications. You can say the limits for this process are X, Y, and Z. And that's actually something we added in this release as well. We added specifications for things like alarm limits, warning limits. So you could say for a process or for the machine, these are the limits for the machine, these are the limits for the process, and so forth. So that was a big addition to this version as well. In 2.4, we added the spatial location. This is basically a geospatial location of something, so you can give actually the world coordinates lat long for a particular let's say device or shop or whatever, or part. We also gave this idea of a narrative location. Narrative was because some things you locate by not by sort of a physical location, because you can't really talk about it that way, but you want to say that you have, let's say, the third door on the right. So, or you want to be able to talk about things like on a grid, or you want to be able to you want to be able to give instructions for where something is. In some countries, actually, the address is more narrative than it is. You go to this intersection, you go 3 doors down. The locations aren't, just like a simple street address. So what we want to be able to do is provide this capability for even things like maintenance, where you open a door, the part is on the right. We want to be able to talk about things in this sort of narrative space. So we provided this narrative location. For some processes, we then added this concept of thickness as well. We're talking about like layers and such. And almost at the end. In 2.5, one of the big additions that we added was this concept of air quality metrics, particle counts and sizes. We wanted to be able to talk about air quality for various different processes that had air filtering required. And we could have things like, an aerosol particle count, the spatial volume, the particle sizes. Could use this also for things like 3D printing as well. So that was part of it. These are sensor types. So if you see a sensor, you can add a sensor to almost any component as well. You can add sensors. You can just have a sense of environmental component types. And then a bunch of sensors is like a 0.3 micron particle sensor that's attached to the machine or maybe in the enclosure or whatever. Another big thing that came up in this release, this is again 2.5, was the beginning of validation. And we now have, if you look in the model, validation reports, and Trey's going to be doing that in the session right after this. He's going to talk a lot about validation. One of the things that we have right now as a capability in the MTConnect agent is the ability to provide, when the header says validation true, this is actually configuration better, but when we turn this on, what you're going to start to see is temperatures and data items coming out with either valid quality valid. This is a valid value, as well as any numeric value for a temperature will be valid. But things like, let's say, my execution comes out as Arctic, that will have a quality of invalid. And we can now stream the quality valid, invalid, or unknown, because sometimes, like an extended type, I don't know whether it's valid or invalid. But every single data item that has controlled vocabulary in MTConnect now has these valid, invalid checks that can be turned on within the agent. And this feeds into your application. So now you know immediately whether you're getting data that's according to MTConnect or not. Trey's going to show you how this can be extended quite a bit to give it what's called an exception report, which tells you like these are all logged. And the agent doesn't support this right now, but it's going to eventually support a reporting mechanism where you can say, give me the exceptions that occurred for all the different data items. It'll tell you all of the invalid information or data that was put into either the device XML file, if there was like an invalid type, invalid subtype, combinations, numeric value where there should have been text, or text where it should have been numeric. Any of those things that occur during the validation phase when the agent is starting up or when data is streaming through will be available via a exception report. Trey's tool that he's going to be demoing actually creates that exception report according to the standard. So now we have a normative way of reporting out exactly what, and this is TAMS that have done this for analytics, they have created a tool that generates this for you. So that was a big change in that version. The other things that we added with in 2.5 were fixtures in palettes. So we were able to represent, so simple. These are simple asset types: a fixture ID, a fixture number, clamping and mounting methods. And again, palettes have the same thing. So you can have a palette which has a bunch of fixtures associated with it, and they can be related. We have a way to do now also asset relationships that are built right into the asset model. So that was also added. So I can say this palette has these fixtures, this fixture is part of this palette, and build out those models in the asset as assets. So we're kind of rounding up on the end of the history. So in 2.6, which is the current released version of MTConnect, we added a new thing, because we used to just had a way to say the asset was either updated or removed. People said this was a bit confusing because you didn't know, was it added, updated, or removed? So sort of we added one extra new way to say that this is part of the data that you get out of the agent. The agent will now say when an asset was added, changed, or removed from the agent. That's all reported out automatically. The other thing is that the agent does this automatically. So even from the adapter perspective, it just pushes the asset or sends the asset to the agent. The agent then records one of these three states. And we added some new error types for asset not found and associations. And an associated asset ID. This again allows us to link assets together. So we can say that the associated asset with a certain thing or something like a process has these set of associated assets. So this is the exception report that I was talking about that will be demoed soon. So basically we have three different types of exception reports. We have an assets exception report, a devices exception report, and streams. So again, these are for your three different document types. Devices, all of the errors that occurred while the device file was being parsed and validated, all of the errors or exceptions that occurred while data was being pushed through, and an assets exception report. So these are all the problems that occurred. So an asset gets updated, like a cutting tool gets sent across, and the XML isn't correct, or the structure of that model is not correct. So again, somebody's used the wrong thing in the wrong place. And then you can have a scope, and scope is basically object, key, value pair, nested object, and this is for JSON or for XML, you have element, attribute, and child element. So basically, depending on the type of document that we got sent, either a JSON or XML document, we can call out that error in a specific type, and then have the scope, like, scope and value and expected type. So this is like if it was, let's say the value was ABC and we expected an integer, this would be, the value is ABC and the string was, expected type was like int 32 or int 64 or whatever. And then we have all these different codes like type mismatch, not found, deprecated, extended, out of range, duplicate entry, invalid format, and so forth. And then the severity. So it could be just a warning saying, this is wrong, but I'm going to let it through anyway. It could be fatal, like you're loading a device and it's just got junk in it, or an error. And for errors, sometimes we'll say, yes, this was wrong. We're just going to ignore it. Data item has garbage, but we'll ignore that data item for now. Or info is just informational, like I'm doing something, or, this is the value that came across here. One other thing that we did is we changed the response from the MTConnect agent. So the MTConnect agent used to just give you a bunch of errors with an error code and so forth, and that was it in the message. But a lot of people were saying, when I'm doing the calls, I can't really parse this very easy because it was just like text message. So I had to parse text, and the text was kind of confusing, and different versions of the agent or different implementations were giving out different structures. So we created this new thing called these error types. So now we have invalid parameter value, asset not found, invalid query parameter, invalid request, and so forth. And invalid URI, XPath, no device. So you put a device in, can't find it, and out of range. If it's either, let's say invalid parameter value or out of range, that will also tell you what the minimum and maximum values were, the type, the format, and the value that was given. And this allows you to very quickly understand exactly what happened from a machine readable standpoint. And again, the reason that we went for 2.0 to a SysML model is because we wanted to make our standard machine readable. It wasn't enough to just have it, a text document being normative, because text you can interpret. Machines can't read text very well. Even LLMs sometimes get confused. So we wanted to make it so that this model, you could take the model, the XMI, and parse it as we've done through the transpiler and convert it into many different forms. You can report on it many different ways. You can validate using it. You can do a lot of different things because now we have an actual model. We created a cutting torch and electrode type as well in this version. And those were for support for things like a friction stirred welding. Finally come to the last release. Well, let me finish that. One more
Perfect.
slide.
Okay, sounds good.
We just added, as I was talking about before, the parts and process. So we have both parts and process, archetype and part. The part talks about the asset for, again, we have like families, drawings, identifiers, and unique. So this basically allows you to do some very simple part traceability. And then we have the processes as they're going to be executed on the machine. In the archetype, we have multiple different routings. In the actual process, we have this thing called a routing. So we have a process. A process can be routed through multiple different machines. Again, just like on a traveler, you have a set of steps that you're going to be doing for your process. So these are all the process steps. What MTConnect allows you is say, okay, these are the different flows through my manufacturing floor for a particular process. It may just be one, maybe it's only one set of machines, but let's say you have 3 different ways of making the part. We actually can represent that as a set of process steps. And activities are what we call things like, let's say, a operation, a tool group, a tooling, let's say, use of a single tool is called an activity. And they can be grouped together if there's like a sequence, like let's say a tapping operation where you have a tap, drill, tap, chamfer. So those would be all the activity groups. So you can group them together or just have one, whatever. And then we have a set of targets. These are the machines that can execute that process step. So we have, either a group or a single machine. Sometimes you have group machines and so forth. So we have models which can now represent that entire traveler and the parts that are being made, as well as we have this new thing called tasks that allows us to represent automation. I don't have a lot of time for that. So that's again, let's leave that for the next time. But basically we have the 3 pieces for automation now. We can to allow you to describe your parts, your processes, and the tasks that are going to be executed on the manufacturing floor.
That's great.
So that's where I'm going to. Yeah. So I'll give the break now. And turn it over to
As you guys can see,
Mike.
we've put a lot of work into this in the last 17, going on almost 20 years. So I've been here about 10. Will and your other presenters have been here almost from the beginning. So it's been a lot of work over the years. Let's take our 5 or 10 minute break. So it's about 20 after right now. So let's come back at 30 minutes on the hour, and we'll continue with finishing up this session. Thank you. Okay, welcome back, everybody. We're at the half-hour point. So as soon as Will comes back, we'll let him continue. And Will, by the way, that was a great job of trying to squeeze 17 years of development into an hour and a half.
Yeah, it's kind of mind blowing when you go back. I've been doing this for so long. How much we packed in there over the years, and how many changes we've made. And one thing I have to say though is that the MTConnect community is wonderful. We've had great participation. We've had, everybody is really collaborative and allows us to make big changes. Like say we're going model normative, or we're going to go over to a model, no longer be PDF, where a lot of other standards get tons of pushback on that. Our group was like, yeah, that's a good idea. Let's do it. It's going to give us a lot of capability. So, just have to throw out to the community that this is, it's been a great experience.
And just a comment to the audience is, all of these features that we've gone through and all these things we've added, it's not something that you have to take on all of it. It's there if you need it, or if your manufacturing requires it. That's what we've been working on for the last 10 years that I've been here, is adding things that individual customers and end users are asking for to better gain knowledge on what's going on their manufacturing floor. And that's the purpose of the standard. All right, Will, turn it back over to you to keep going.
Yeah, that's what we rely on, is everybody to help us out. I just want to show you quickly, this is where I got all the version information from. So if anybody wants to do this, it's model. You just go to, that's actually model.mtconnect.org right there, and click here, and version additions and deprecations. And you can see everything we've done, introduced, deprecated, etc. like the asset models. There's a new model we just came out for 2.7. We're reviewing it slightly differently this time. Like this is the task models and everything else. So if you join up, we'll give you access to this, and you can start to see how we're putting things together. So this is a detailed document that shows all the model. Anyway, just wanted to show that to you so you can kind of get an idea. Yep.
Before you jump back in, one little comment on that. When you look at what's in all the versions and the things that have been deprecated and added, the first probably 5-7 years of creation of the standard, everything was brand new. We were just trying to get our feet wet. So you'll see a bunch of things that were deprecated. Look at the long list of deprecations. Now that the standard has pretty much been on an even keel for a number of years, especially since version 2.0, the deprecations are very minimal, if any, because we're focused at the working group level to make sure that when we introduce a new concept, that we introduce it at a minimum level to get started, and that way people can tell us what we need to add, but we're not deprecating things that you already have supported in one version, and now you got to back it out in another. So we're trying to keep the deprecations to a minimum.
And also see previous versions as well if you want. All right, so yeah, so that's true. Yeah, we're getting much more stable, and a lot of additions, a lot of new stuff. But here's so those are mainly just features. Anyway, so I just wanted to jump into that quickly. I'll jump back to the slides now. Again. And okay, so we're going to talk a little bit about Neil touched on this yesterday, and I think just want to go over it once more. So we have this decision of how to configure your agents. I think Neil and I kind of differ a little bit on this, but basically you can have machines out there with adapters running either on machine or at the edge or on the network on like the same machine as the agent. And you can have one agent that has all of these machines on it and one port open, like a firewall up there. The pros are basically you have one port exposed for all the machines and one folder with all the configuration and fewer processes. And it takes up a little bit less resources because you only have one process running for all the machines. But then again, if this one machine stops, basically you lose data for all your machines. Everything is split between all the circular buffer and everything is split between the two, all the data items on all the machines. So all the observations are split on that one machine. It has a higher CPU because it's serving 4 machines, so it's 4 times at least, or maybe a little less. And as Neil was showing yesterday, you have to make sure that all of your IDs are unique for all your data items, components, everything. Everything in a document has to have a unique ID. Now, there are some tools for that out there. The agent actually, when it's aggregating, or there's a thing that now the agent can do, which is create a unique ID for all of the items in the devices file. So if you are interested in that, we can demo that sometime in the future. And you need to then, when you're making a REST call, you need to specify the device name or UUID instead of just being able to say, / probe current sample. You have to say, device 1 probe, device 2 probe. Or if you do without anything, you get all devices or probe sample current. You can specify the device, but then if you want to just look at one device, you have to do that. The other option is you do one agent per machine. And again, like you have one agent here, same basic configuration, but I have, 4 separate agents running. These could be VMs or they could be actual machines. And then they connect up to the network. Again, you have your network protection. Pros, you get one configuration per machine. So one device.xml, one configuration settings. So it's a little bit easier to manage that way. one buffer for each machine, so you can always tell whether you have collected every single thing from that machine. So, sequence numbers are going to be only for one machine. If you want to upgrade one agent, you just have to change the configuration for that one agent. And you can, again, do this simpler request to the agent without having to specify the device. So if you need to put the device name in there, it's optional. And if you just want to get data from a machine, and the process has a little bit lower CPU for that one particular agent. The cons are you have multiple configurations to maintain. So yeah, one configuration per machine. Well, now you have multiple. And you have many output ports. So from a networking perspective, if you're dealing with your IT department and they say, well, we only want to punch one hole through our firewall, then you have to have them punch multiple different holes through their firewall. So they have to say that it's okay for the application to hit these machines or these ports on this machine for each of these different agents versus having just one port to manage. And it's more processes to manage. So, you have to make sure that more processes are staying up. And again, in aggregate, it's probably going to be more resources. And then there's going to be more connections per application. Because in an application, if all of the machines are on one agent, it can just connect to that one agent and say, get data from all the machines at the same time. So stream me all the data. I don't care. And so there's, it's a trade-off. I know that Neil is very much in favor of the one agent per machine configuration. And personally, I've done implementations where we've had, up to, let's say, 50 machines on one agent. It really depends, on how you want to manage your information and your services and everything else. It's a tough topic. I'm not, again, we could probably do an entire session on pros and cons and look at, when we actually dig into it, like from you have something like a container management system, like let's say Kubernetes. Let's say you have a container, all your agents are running in containers, and you have a system to manage all of those. Well, maybe, then it's very easy to do that with one agent per. But if you have like a machine somewhere central and you want to just have a single configuration that you manage and you can, add and remove stuff to it, maybe easier. Again, you have to deal with the ID issue. But that's a problem. And that's, I think, what really threw Neil was basically having to deal with all of the ID mapping and making unique IDs for every single machine. Which I agree is a pain. The way we used to do it back in the day when I was doing a lot of deploys was the previous life. We used to have a tool which generated that entire configuration. So it was automatic. We made sure that all the it wasn't like, editing in Notepad. We basically, everything was generated automatically. There are now tools also that can help you with that too. Uh-oh. That wasn't, somehow it double pasted. Sorry about that. Yeah. Reshare. Sorry, these, the latest, I think since like 2.2 or so, we have this thing that we can do, which is called an agent adapter. I just wanted to throw this into the mix, just to add to the confusion. The agent adapter allows for you to actually create an agent with actually an empty devices file. It just says devices, no content, no nothing. And you set that guy up and you tell it as adapters all of the agents you want it to read from. And it replicates the data from all of these agents dynamically in this guy and then publishes it out. So let's say you wanted to create an OT network that had a firewall on it that exposed these ports, but then you wanted to block any access from your business network or your cloud. You could create like a demilitarized zone, a DMZ, which basically is a area in your network that will allow you to limit the traffic only to this point. So only this external network can touch this process here, this port on this machine, and then only this particular process on that machine can get access to this network. Usually these are two separate network, either virtual or physical network adapters that are here. And so you have the front-facing, outward-facing network, and or the northbound and the southbound. And that, yeah, yet another option. And the agent will actually automatically take all of these guys here. You can have it create unique IDs for you. There's a create unique ID option now. So it will pull all these guys in, delta the changes, if there are any changes, save that device XML file with all of the aggregates in it to the file system, version that thing. So even if these guys change, it will automatically version that. And then serve up data going out the other direction. Again, you have to have a buffer big enough to be able to support all of these guys, but that's yet another option that is now available since I think like 2.2 is when I added that capability. Yeah, this is kind of the best practices part of the talk. So another thing with polling time. So if you're going to be doing, as Neil showed yesterday, you can do in intervals, so sample with an interval, right? So you can say, give me updates every second from the agent. If your adapter is only sampling the machine or getting data, polling it every 4 seconds, this is kind of useless. You're not going to get data any faster because you're on a 1 second interval. If this guy is 4 seconds, you can set this to 4 seconds. It's not going to make any difference. If this is like, let's say 10 milliseconds, you can still do 1 second interval, and it will batch up all that data and give it to you in one shot. That allows for high speed data to be combined together so that from an application standpoint, it's much more efficient to process. It's much more efficient on the network as well. You send tiny little packets, lots of them, like lots of data over the network, very fast. What happens is you can overload your network. If you send data as chunks, you can make it much more efficient. And depending on your application response times, this is where it's going to get interesting. So,
Will, is there a way to tell from your adapters what the output is from each individual machine?
There's a way that they can announce that. Actually, there's one of the control variables they can send over. You can also, there's a configuration. There's actually an interval in each of the components, which will tell you what that's supposed to be set at. But right now, it's not required. It would be good actually to try to push people to give us that information about what their sample frequencies are. The thing is that sometimes each like I know a lot of adapters have different frequencies for different things. So you may be polling, let's say, your telemetry, your position data every 10 milliseconds. But you may be checking your controller states every second because they just don't change that fast. So, or certain things like modes, like your controller mode, you may just say, okay, fine, let's check it every second. That's not, unless the operator is going crazy and with the dial, it's not going to happen. So basically, what we find is that things like, if you're doing, like, let's say, OEE or utilization analysis, you don't really need really high speed data because you can get like data at less than 1 second, and it's not going to make any difference. If you're doing something like, let's say, predictive maintenance or predictive analysis and you want to see if something is going wrong, then you start getting into like, let's say 50 to 100 milliseconds range. And this is also important if you're going to be integrating in automation technology. So let's say from a robot to a machine tool to coordinate activities like, let's say, opening a door, putting a part in place, closing a chuck, and so forth, which you can do through interfaces. That data you want to get within, let's say, 10 milliseconds or 100 milliseconds, so that you can basically have very fast response times. There's no delays. There's no, the reaction times are very fast. You can actually have, in using the agent, you can have different requests going out at different intervals. And you can say, okay, for my monitoring, I'm going to do, let's say, 5-second intervals. And for my integration, I'm going to do, let's say, 50 milliseconds or 100 milliseconds. And then I want to go for, my adaptive feedback. I want to check when I see the load spike to this amount, let's say to 100% suddenly or 200% suddenly, I want to immediately back off the feed. Well, for those kind of things, we're dealing with like less than, 25 milliseconds. So MTConnect can actually operate in any of these ranges. And again, we can limit the data at the agent, we can do different polling frequencies and so forth to be able to get data back. And you can, with the path, you can specify exactly what set of data that you want. Usually data from MTConnect resides somewhere sort of in the 50 to 100 millisecond range for most of the data that I've seen. Like, for most, like, let's say, modern machines that are doing fairly high speed sampling, you're going to be somewhere in this range here. For some of the older machines, and especially for like legacy machines, which have, let's say, just a bunch of relays hooked to a terminal block, then you're going to be dealing with lower sample frequencies, probably somewhere in the second range. Because basically what you're doing is you're looking at things like stack light states and modes, controller modes, as a set of bits coming off of the wires. So it really depends on your use case, what speed you need. But a lot of times you can sort of rely on something being in this space right around here for a lot of what we do. Another piece of sort of best practices, I'd like to understand, get you guys to understand also how timestamps, and Neil went over this yesterday, but just to kind of lock it in, we're going to do a little bit of a sample here where we're going to talk about where the timestamps are occurring, and a little bit of a quiz here, though I can't get any feedback from the adapter to the agent. So if right here we say ignore timestamps is false, where do you think the timestamp is going to be taken from? The agent or the adapter? Everybody give their response. I can't see. It's going to be from the adapter. So the adapter is going to supply that timestamp, and this is going to be honored right there. If, on the other hand, ignore timestamps is true, where do you think the timestamp is going to happen? The adapter or the agent? A second to think about it. It is going to be on the agent. Again, what's going to happen is ignoring this timestamp that's coming over in the adapter feed. Let's say the ignore timestamps is false, but there is no timestamp. Where do you think the timestamp is going to come from? The agent. So the agent is going to supply, if the adapter cannot supply a timestamp, let's say it doesn't have a clock or it doesn't know anything about time, we're just going to say, agent, you supply the timestamp. So timestamps, basically, we have issues with a lot of machines. And the problem is that sometimes even machines, one type of controller once, that it was shipped and the clock was set. And it was actually, for some reason, I don't know exactly why, the manufacturer did not allow the user to change timestamp. I think it was for licensing or whatever, but they could not change it. So, and it was always wrong. So basically, there was always the wrong time coming from the machine. So basically, you can have date errors, time zone, daylight savings time. Usually it's not in UTC. MTConnect requires every timestamp to be in UTC. We don't allow time zones as part of the standard. So when we get dates and times from machines, we can get sort of a mess. So one other point here is that we can do timestamps on a per machine basis. So let's say we have 3 machines here. Top level, ignore timestamps as false, but in D1, this is again with the multi-machine configuration, I have ignores timestamps as false, D2 is true. What do you think is going to happen here? Hopefully you know what's going to happen. So what's going to happen is basically we're going to have timestamps honored only from D2 because D3 inherits from the top, D2 overrides. So the agent is going to have to supply timestamps for D1 and D3 and not for D2. One thing that I think wasn't covered originally is this concept of relative time. So relative time is when you know your clock is wrong, but you still want to honor those times because you know the delta between the time is going to be correct. And you may have some transmission delays. So what we do is on the first observation that we receive, the first thing that comes across, we take a delta. So we say, okay, in this case, the time on the adapter is 11:15. The time on the agent is 11:16. We know that there's a 1 minute difference between the adapter and the agent. What we do is then we apply that every single time. So let's say an observation comes across and has a timestamp of 11:20. But sorry, on the agent, the time is 11:26. We'll ignore this for the moment and we'll say, okay, there's only a 1 second difference between my clock and the adapter clock. Therefore, I'm going to just apply this delta to the observation. There must have been a delay. Maybe there was a network delay. Maybe the adapter got stuck. Who knows? But basically, we're going to say, okay, we're going to honor this time and apply that known delta to it. It's a pretty simple solution right now. It just takes the first, assumes sometimes normal, there's no network delays or other delays involved, which is, theoretically what we should do is probably, send multiple packets back and forth and find like an average or a heuristic or whatever. That maybe if you want that, we can do that in the future. But that's what when you turn relative time on. This is the behavior. It can be turned on again on an adapter by adapter basis. You can also supply not actually a time, but just a number. It supports 2 different things. I have an example of this, sorry. The number is just milliseconds since some 0 point. So when that comes across, we'll note what that number is. Let's say like 10,000, and then every 1,000 after that, we will calculate numbers milliseconds since this initial time that it arrived. So you can also do this is often for things like if you have an Arduino or a sensor that doesn't actually have a clock, but just knows how many ticks or how many seconds since the thing powered on. And you report that out, and MTConnect can deal with that too. And we'll create the correct timestamp based on that progression. The next thing is part counts. So MTConnect does not automatically increment the part counts. So when a part gets made, basically you need to report that from the CNC. So you have to implement that on the NC programs. We do provide the ability to say when they're reset. So if the NC can also report that out, we can do things like say that a part count is going to be reset every shift. I talked about this earlier. The way you do this in Shutter is basically you add a colon. So here it's going to be reset to 0 after every shift. And again, we have all these different types like action complete, annual life, day maintenance, month power on, etc. So basically, you can say this is going to put an extra attribute on the observation side of things on the stream stock. That's going to say the reset was triggered because of the shift, and I can lock that into only be shift for these guys. So I can actually announce this data item will get reset every shift in the metadata in the devices file, and then announce it when it does. And that just tells you, if there's part count goes from 5 to 0, why did it go 5 to 0? Oh, it was a shift. Or, let's say you're making 100 parts in a shot, and when the action is complete, it resets to 0. You can say that, and now we know it wasn't because somebody just randomly reset the counter. I talked about this a little bit earlier. Basically, we have this flow of information that comes through the agent from the raw data. We aggregate. Again, we can aggregate data from multiple different places. And this is one thing that we talked about a little bit before, is that you can have multiple adapters, like you can have a Shutter, MQTT, and whatever, an OPC, UA, adapter or data source coming into MTConnect, providing that sort of raw data using just like tag value pairs or some kind of content. And then we at the agent side of things is when we start associating that data, converting it, making sure it's in the correct form and everything else to our semantic model, to our information model. So we provide things like, the context. What we mean sort of by semantics is that we provide context and meaning to that data. So, positions are going to be in millimeters, and they're going to be part of an axis. So linear x-axis is going to have positions, going to have loads, rotary axis, rotary velocities, controllers, execution, et cetera. So basically, we provide that. A next step in sort of this processing is to identify, as we're getting a delta change, when things are changing. And this is what we call complex event processing, which is sort of an enrichment process. So basically, you take the data coming off of MTConnect. Now you know the meaning of the data, same for every single machine. We have all this data that's been aggregated together and pulled together, associated in the right place. We know the context. Now we can start making some what are called higher level events. We can start enriching that data and finding like intervals of certain operations when you're working on certain parts, whether, how much time you were spent active or ready or stopped, or, what states were you in, what were your functional modes, where are all your offsets. So that's all what you can determine at this stage, which then leads you to analytics. When you start doing your analytics, you can start getting into things like, what was I doing during this interval? Was I, when I start bringing in my business systems, I planned this process for 1 hour, but it took an hour and 15. What happened? Why? And somebody changed the feed rates. It really takes only 30 minutes, but we thought it was going to take an hour. Why? What was changed? So we can start doing all of that analysis by contextualizing, again, the data, bringing in the business processes, and doing some of our analytics. We can start to understand whether things were good or bad, how they were affected. We can start applying some it's called industrial analytics or industrial AI to it, where we can start, putting it against statistical models. So take statistical models and finding like, what is my golden process? What is the best way I've ever made this part? Locking that down and then comparing every other run to that. So I can start to really get that feedback loop that tells me how I was doing, when things went wrong. And then you start getting into predictive where I can say, okay, I can see that things are starting going bad in this process. Let's, send out some alerts and, try to stop it before things get worse. So that's where we can start getting into some more interesting analytics. Types of things you can do with it. Of course, we talked a lot about utilization, tooling analytics. I can start to understand things like how my tools are being used. What are the feeds and speeds? What are the best feeds and speeds that any operator has ever used for this particular tool in any part making a certain type of feature? So I can start asking questions like that. I can now, especially with parts of process, I can do track and trace. I can say, okay, what was the life cycle of this part? Where did it go? Which machines did it go to? How was it made? What tools were used? What process was chosen, etc. How was it measured? What were the measurement results? How did the measurement results compare to the initial design, and how did that then compare to what was happening in the manufacturing process? Can I get any sort of signal as to why things were going? Maintenance. Okay, my part didn't measure correctly this time. There's something wrong with the machine. Did somebody, slam into a clamp or something? Was the machine operating in a way that showed that there was an extra vibration, or there was a coolant issue, coolant concentrations were off, et cetera? Uh, um, did I get any oxidation on the part, et cetera? So basically, other maintenance issues associated with it. And then, we can start getting into things like circular economy, using, recycle, reuse, and all that kind of stuff. So basically, that gets you out into, the larger sphere of how do we use data from the manufacturing process to understand how efficiently we're doing sort of a global environment. So there's a lot of different things you can do with this stuff. There's, dashboards that can be, from machines, tablets. There's a lot of tablet systems out there where you can add additional information, additional context, operator feedback to the particular um, intervals or to the particular data that's coming in. This can be also done through cell phones. I can do cell phone monitoring. I can get alerts as either through the apps or text or emails or whatever. And, jigger schedules based on information that I'm getting from the machines themselves. So I can get, real-time track, trace, maintenance, tooling data, and that can help me do things like dynamic scheduling and process optimization right from the real information I'm getting from these platforms. One thing that, like with operators, one of the things that we found is that in the past is that this actually becomes a good tool for operators. Operators can then track exactly what's going on and signal issues like, there's quality slips, there's maintenance issues that haven't been dealt with, or machine problems or program problems that, they need to have fixed upstream. Maybe they had to edit or change something, or, change overrides in a certain place. Those can all then be factored in. So now you're getting sort of towards the digital twin closed loop. And that's where we can go with MTConnect. So, it's kind of this open data stream where we can, enable a lot of future capabilities that we don't have right now. Again, the implementations have to get to the point where we can take advantage of a lot of the capabilities that are already in the standard that I went through before in the history. And once we have that, that was the original idea. I mean, we started this thing to enable smart manufacturing and next generation stuff, automation, and being able to get that feedback loop so we could manufacture more efficiently and increase the amount of products and services we could offer. So this basically using cloud compute now. I mean, we have immense amounts of computing power in the cloud, especially with some of the uh, new like AI chips and things, like NVIDIA chips and things that will give us a lot of new capability. But we need the data. Even things like, you may have the best computing system in the world in the cloud. If you don't have the data to support it, you still got nothing. So what we need to have is, again, from the machines and from this low level down here, from the MTConnect level, we need to have that flow of information so that we can enable all these great things. So from a data pipeline, I mean, if you're using like proprietary solutions, the problem is you're not using standards. You basically have this back box, and and you have this application that is running on this shop, and basically it works. But if you want to do anything else with it, you're stuck with the one proprietary solution, and that means that basically you don't have any additional capability you can bring in. One nice thing about MTConnect is it is agnostic to that endpoint. Any application you want can use it. So you may keep this application that uses MTConnect and just augment it with additional capabilities. Here, if I want additional capabilities, I got to basically write a check to whomever is providing me this solution, and I only have this one solution available to me. Now what we can do is we can start doing a lot of different things with MTConnect. It has a lot of different ways to get the data. It can support applications that do like MQTT, JSON, XML, REST, whatever. Basically, we can have pluggable syncs for things like, Spark Plug B or whatever the hell you want, OPC UA, and suddenly, we can enable that whole thing. Then again, from a hosted environment on my shop, then I can start going into the cloud and again, getting that data into the cloud so I can do larger, bigger analytics and start doing more things with that data. When we get into sort of a full cloud application environment, even with like a multi-tenant solution, that's when I can start getting into some economies of scale for the provider so that they can even provide more analytics and more capabilities. Again, depending on your business, this may or may not be something, but basically when you get into the cloud hosted environments, we have a lot of capability here to bring to bear. And the cost, because you're dealing with dynamic resources, is less. In other words, I'm paying by the hour for these resources. So I wanted, let's say, do some really intense calculation. I can spin up a GPU machine with a lot of compute, fire off my analytics, and then shut that whole thing down. So I don't have to like keep a whole server farm myself. So basically this is probably, going to be where a lot of the smart manufacturing analytics are going to live, is in the cloud. We still have all this stuff at the edge. So we still have our application. We can still do whatever we want. And we can even run these both in parallel. And so these are all options. This is all enabled because we're using a standard. Because we're not proprietary, basically we have all these different options available to us that, we can flow data to anything. So we can enable, a local dashboard that's running right next to the machine on the edge. I can, we can have a centralized reporting system. I can have a cloud-based system, all this stuff. It just, kind of works. I can have device integration. I can integrate a bunch of devices that are talking to each other within a cell on a separated network. And that's all good. So we can also use other protocols. As I said before, we can do things like OPC UA. So, if let's say somebody wants to go into Microsoft's Azure cloud using some DTML platform, a digital twin, model language, which is their thing. And we want to go in using OPC UA to drive that, yeah, we can do that. MTConnect has a companion spec. We're good to go. So basically, what we've done is we said, okay, whatever the application wants to consume, however they want to do that, we will try to enable it in the most effective way using whatever that protocol representation is that works for that particular app. And MTConnect provides the model. We have a model that provides consistent, called normative, standardized, canonical dictionary of terms and structure that allows anybody to understand it. So that I'm going to shift a little bit into security. Security is basically role-based. So basically, when you think about it, you have different people requiring different roles within the organization. Your data science is going to be analyzing your data. They're going to be running, your statistical analytics on it, trying to find trends, limits, clustering, all that kind of fun stuff. Your security organization is going to be managing the various different access points, the VPNs, basically all the virtual private networks, as well as the isolated networks. So they're going to breaking your networks down into separate virtual networks, and then controlling data flow from different points on your network. They even be very sophisticated in using some like machine learning algorithms or packet analysis, packet sniffing algorithms to determine if there's anybody who's trying to either spoof or get in there when they shouldn't be, and managing all the routing tables and all the rest of that stuff. At the facilities level and the OT level, we're going to be configuring data points, sensors, and basically putting together all the edge, basically all of the data collection points, and making sure that my machines are secure, that no data, no connections, nothing is flowing to those machines that shouldn't be, because they are vulnerable. And especially the older machines, those operating systems, those connections are very vulnerable to viruses and to attacks. So basically, the adapter agent as a two-part separated set of responsibilities allows you to make sure that you can separate that traffic and lock down the communication between those 2 points. So the next thing I'm going to talk about, because we're running low on time, is certificates. So one of the things that MTConnect added in around 2.0, because 2.0 we upgraded the agent as well to the new platform, which allowed us to do secure sockets, HTTPS, TLS, and which is transport layer security, which is basically a key exchange. So the simple way, when you turn this on, what happens is you will get the application connecting to the agent. The agent has to have a certificate on it, and you can configure that up. There's some instructions on how to do that, how to create either self-signing certs or have a signed certificate. I can get into all that because that's a whole separate discussion. But you then have the application connecting to the agent. There's a key exchange process. The application verifies that that agent certificate is correct. And then forever on after that, they just communicate using encrypted data. This is, a public-private key. I have a private key over here, private key over here. I encrypt using the private key. I decrypt using the public key, and vice versa. So basically, we are exchanging data using the same technology that's used like to access your bank account or any of those other things. Same exact mechanism. There's one other way. We don't have authentication built in yet. It's something that we're considering. We need feedback from people who are doing security for that. Exactly what do you want? But right now we have what's called dual certificate authentication. So from again, during this key exchange, I have my certificate over here. I have it over there. The agent validates my certificate, and I validate the agent certificate. So we make sure that we're both valid. The way you do that is this thing right here called TLS client CAs and TLS verify client certificate. Specifies a file that contains additional certificate authority. So basically what I'm doing is I'm saying that I am validating this client is allowed to access me because I know the authorities, the valid authorities who can sign the certificate. So every certificate has to be signed by somebody else. And I can then say, if the certificate is not signed by a trusted authority, then don't allow that connection to go through. Client can do the same. If this certificate is not signed by a trusted authority, I have the same libraries and the same capability, throw it out. And same thing that actually MQTT uses the same mechanism. It also has a key username password. We could do something the same like that. But basically, this is a simple way of doing two-side or bidirectional validation or agent application validation by managing your certificates. That's about it. I kind of worked through a lot of material quickly, but these are some good places to find information. The MTConnect.org is basically general information about the Institute itself. Things like registration for this boot camp are up there. Future boot camps are going to be up there, as well as information about getting started with the standard and joining the MTConnect organization. There's the GitHub site for the CPP agent, which is C++ agent. That is the reference agent, and it's pretty much what we've been talking about through this boot camp. And this is the model browser, which I showed you briefly before, which shows you all the versions and all the model diagrams and everything else for all the versions up to 2.6, the currently released version. The other site, actually, I didn't put up here, is projects.mtconnect.org. That is our site for managing all of the day-to-day for the Institute activities, all the working group activities, standards committee, as well as the executive committee. So with that, we are actually done.
Great. Well, that was a very informative session. I hope you guys got a lot out of it. I know I did. One thing that I want to add to that is we are going to have an email address that we've created for follow-up on this boot camp. We will be publishing that at the end of the last session, and we're also going to put it into the emails that's going to go out to all of you guys with the follow-up information. Now, you'll have to give us a few days, sometime next week, before those go out. We've got some homework to do to get everything assembled and put together so we can send out the slide decks in PDF format and also the videos. The videos you should be getting emails on almost immediately after these finish. AMT's doing that for us, and I've already seen almost all the sessions prior to this one have already gone out, so you should be getting those. One thing I would like to add, if you're staying around for the validation one, we are going to have a few minutes at the end. We're going to ask Will and Neil to come back and join us, so the four of us will be live on the meeting, so we can do a final wrap up and get your feedback, and then do some Q&A with the four of us able to answer questions for you. So we're going to take a lunch break now for a little bit, and we will see you guys at the start of session 6.
Yeah. I was going to say, are there any sort of last minute questions? I saw there was a lot of chatter.
Yeah.
Going on.
There was a lot of chatter.
Yeah. Mars time coordinate. Sure.
My question is, how do we get the parts back from Mars? That's my problem.
I think, they can stay there.
Yeah, that's true. I think that's one we'll have to ask Mike Bosfeld from Stratasys about can his machines operate in a Mars environment. All right, anybody have any last minute questions for Will before we end this one?
Benjamin Stanfield. Let me see. He only gave me a partial answer on that. And I see a lot of discussion about Mars. High frequency data. So things become TMAC system, but just Yeah,
Ben
so
was
for high
asking
frequency data, I mean, yeah, so there are some use cases for it. A lot of them have come down to like predictive maintenance and management. I wouldn't say so. Like you're talking about TMAC, you're talking about like care and engineering and real time feedback. When we talk about real time is a bad term. It means basically response within the time that's necessary to be able to make an informed decision in an effective process. Okay, what we're talking about is like very very low latency, deterministic. Let's say deterministic um, time frame. Deterministic time frame means that you're sometimes operating at even the sub-millisecond level. You're talking, you're into your nanos. And for things like that, you really are residing on the control system. You're looking at things, you're looking at your loads, data coming off of your Hall effect sensors on your spindle lead. You're measuring the amperage and power going to and you want to look for like a spike in the current, and you want to be able to react within like a millisecond. So to be able to do that, we're really beyond, I guess, what you'd normally say is the MTConnect space. MTConnect is kind of, as I said, it's usually like in that sort of 50 to 100. We have done like for sound and I know vibration sensing that Trey's done. We've done that. They've done high frequency, up to like 4K or so. That can be done. And there are some usages for that. Like if you want to do, let's say, a vibration sensor and have very fast data coming off, we actually had somebody work with us on this a long time ago, and their opinion was, it's unnecessary to do the high speed data. Let's just bucket it and put into a histogram and do a fast Fourier transform, an FFT on it. So we started actually working on FFTs, but then we found out there were too many flavors of FFT out there. But the end result was that often what you want to do with super high speed data is upfront processing. MTConnect can actually handle it. And we just haven't had a huge number of use cases. I guess maybe Trey and John can speak about that at another meeting because they have some really interesting technology on that, and that could be actually part of another session.
So, Will, we had another couple of questions on the certs and the certifications that Jay brought up here. Yeah. He had two questions. Is how do certs work with protobufs, and does the usage of certifications influence frequency?
Okay, so we're not using protobufs right now as a representation for MTConnect, though we could. In the Sparkplug B standard, it is using protobufs. We do use protobufs for Sparkplug B. For certs itself, I mean, certs puts an overhead because you have an encryption and a decryption overhead on it. And it really depends on what type of equipment you have on either side and what kind of acceleration. Do you have GPU acceleration? Can you accelerate the computation of that certificate? I think the technology right now can do very fast encryption. I haven't tested. That's actually something that would be interesting to test. Exactly where the limits are when pumping data out of the agent. Again, from the adapter to the agent is unencrypted at this point. And we have had people ask, should we encrypt it? That's something else that we need to talk about at some point. Could be done. So far, the use case hasn't come in there yet. For outgoing data, we do combine data together so that, let's say even high frequency, if you batch it together into globs, it amortizes the amount of overhead for each packet. So I think you can still have fairly decent efficiency while having encryption turned on, though that is a good thing that we should test.
So one comment on that, Will,
Okay,
the certs, are they internal or external? So do you have to reach out to a third party in order to get your certification verified, or does that happen internally?
There are what are called self-signing certs, and which you can do through your organization, or signed certs that can be assigned by an authority like VeriSign or Let's
Right.
Encrypt or one of those organizations. Those are what are called root sort of cert authorities. Your machines have a set of those root sort certs in them already. That's how your browser works. You know, when you connect up to something using HTTPS, it's actually validating that service cert. Whenever you get that big red message that comes up that says this certificate is invalid, enter at your own risk. That's basically what's going on. That cert is no longer being validated by the root cert authority. So let me just jump over here for a second. I'll show one last thing. So if we go to GitHub, I have an example of it actually at the end, of the README here. It's also in the documentation. There's a little bit of instructions on how to create a cert. So it's creating testing certificates, gen certs. So I actually have a cert for this, a certificate for script for this, but basically you can do all of this fun stuff. This is with OpenSSL. It's a library, installs on most platforms. Unfortunately, this is command line, so it's not for the faint of heart. But basically how to create that certificate, your self-signing authority certificate. Again, that's not going to be backed up by any root certificate. You're just basically saying it's me. And you can create one for your organization and then distribute it. That's what that certificate CAs thing that I showed before is. It basically says, this is my certificates for my organization that have not been signed by some trusted source, but I trust. So then you create a user key, a signing request, a user certificate using that root certificate, what are called DH parameters. And then you verify that all your certs are okay, and your both your root cert and your service cert. And then you create client signing certificate, your client key, and your client signing request. And you have to create a configuration file, and then all that stuff. So it's a lot. But that's, you know, if you have an IT department, they'll know how to do it. If you go to if you get a site, a cert from a signing authority, they will do all this for you. You just basically cut and paste it into a file, configure the agent to point to that file, you're good to go. So, and the parameters for that are, let's see, they're in the security section right here. So basically your TLS certificate chain, your password, you put a password on it when you set it up. Your client CAs, that's when you have validation on the server side. DH key. This basically says, I only allow TLS connections, HTTPS, nothing else. Any other connections are using just regular good old fashioned HTTP. Throw them out. My private key. And my, this is a flag that says yes or no. Validate those client certificates. So those are the parameters. This is all you got to configure up. Again, this points to a file on your file system. It contains that file. All these things, basically, this is a file as well. Password's not. DH key is a file. Those are your Diffie-Hellman key files. Anyway, this is getting a bit too much, but basically, fun with security. But that's the same. It's very similar to what you do when you configure TLS with NQTT or any of the other platforms.
Great. Thanks, Will. That was very informative.
Yes.
Let's take our lunch break at this point, and session 6 will start up in a little over, let's see, an hour. So we'll see you guys for session 6. Thanks for coming.
Okay. Thank you. I was going to reply to a few things here.